All right, today we are taking a look at different types of number relationships. And we are going to start just by looking at factors and multiples and the difference between the two. So, factors are basically numbers that divide evenly into another number. So if you think of like what times what equals a number, those two numbers that you're multiplying together equal the factor. So a lot of times we think of factors as factor trees, hence the picture there. So when we look at 18, for example, we can find factors of 18 by thinking what times what equals 18, or what 18 divided by what equals. So we could have 1 times 18, that would be a factor pair. 18 is an even number, so we could also do 2 times 9. And our third factor pair for 18 is 3 and 6. So in other words, factors of 18 would be 1, 2, 3, 6, 9, and 18. And sometimes I've seen it where students have been taught like factor rainbows. So every factor should have a pair. So for example, 1 times 18, 2 times 9, and 3 times 6. So that's a nice way to figure out if you have all the factors. So think about what times that number would equal that number. So those are factors. Factors are the building blocks. Multiples, right, keep going on forever and ever and ever. So we can keep adding to our pyramid, whereas like with factors, there's a limited number of each. So a multiple is the result of multiplying a number by a whole number. So for example, 4 times 1 is 4. That's going to be the top of our pyramid. And then 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And all of these would be multiples. We could also just list them out, and you could skip count 4, 8, 12, 16, 20, 24, and so on. So multiples are infinite. They go on forever. Whereas factors are set. It's like a stop sign. There's only so many factors that go into another number. And we're always just talking about whole numbers. Sometimes there's decimals and things like that, but with factors and multiples, it's always whole numbers. All right, so we're going to practice finding the factors and multiples of some numbers. All right, so for example, 4, we did that already. We just went 4, 8, 12, 16, 20, 24, and so on, because 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on, right? So now I want you to pause the video and come up with the first 5 multiples for 7 and for 11. All right, so for 7, we have 7 because it's 7 times 1. And that's one of the things you always remember is the first multiple of a number is just that number itself. And then we have 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And 7 times 5 is 35. So that would be our first 5 multiples of 7. And then for 11, 22, 33, 44, and 55. Because once again, we're just taking 11 times our numbers. All right, for our factor pairs, we can either do it as a rainbow or we can think of it as like kind of the factor tree. So with the factor tree, right, so 24, what are 2 numbers I can multiply to get 24? Well, you have 1 and 24. We could also do 2 times 12. We could also do 3 times 8, and that would be 3 factor pairs, but just to finish it out, we could also do 4 times 6. The other way we can think of it, and I'm going to skip down to 72, is you could make a list. So like 1 times 72. So our smallest factor, 72, is 1. Our biggest factor is 72. And then I might go to my next number and think, okay, well, 72 is an even number. So I know it's 2 times 36. 72 is divisible by 3. So it's 3 and 24. 72 is divisible by 4. So it's 4 and 18. It's not divisible by 5 because it doesn't end with a 5. It is divisible by 6. You have 6 and 12, and I'm running out of space. It's not divisible by 7. It is divisible by 8, and then we'd have 8 times 9. And the nice thing about using kind of that rainbow strategy is, as you can see, the numbers get closer and closer together, and now we know 8 and 9 are right next to each other, so there's no other factors. So why don't you pause the video and do 18, and then see how you do on that one. All right, so 3 possible factor pairs for 18 would be 1 and 18. Oops. 2 and 9, and then 3 and 6. And now that we've talked about factors and multiples, we can start to also look at those numbers and how they break down and what their relationship is. Because factors and multiples end up relating to what we call prime and composite numbers. So I've included a couple different visuals on this. So our first visual is over here on the left, where on this side we have prime numbers. So like 2, 3, 5, 7, and 11 are all prime. Whereas 4, 6, 8, 9, 10, and 12 are all composite numbers. So when you look at that image, what are some things that you notice is different between our prime numbers, which are over on the left, the blue, versus our composite numbers? And then even over here on the right, when we look at all of these circles, notice, for example, 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17 is prime, 19 is prime. When you look at these, how do they compare to all of those other numbers? So hopefully you started to notice that with our prime numbers, like 2, 3, 5, 7, 11, with this visual, or with our circles, there's only ever one group. So like one group of 2, one group of 3, one group of 5, one group of 7, one group of 11, or just a single color, and it's not cut up any other ways. That's because prime numbers are numbers with exactly 2 factors, and it's just 1 and itself. Meaning that there is nothing that you can multiply together to get that number except for 1 in itself. You can't make smaller groups without having to break a number into fractional pieces. So examples of prime numbers are 2, 3, 5, 7, 11, 13, and so on. Because each of these cannot be made into smaller groups. So if you had 13 students and you wanted to split it into equal groups, you wouldn't be able to do that. It would just have to be one group of 13. Whereas composite numbers, right? So these numbers over on the right in red, or are numbers that are split up or have multicolors to them, because we are showing that we can make other groups besides groups of 1, and so they are numbers with more than 2 factors. Okay, so that's that big thing. There's more than 2 factors. So here you can look in our visual with prime numbers. It's just that simple circle because it's one group of that number, whereas composite numbers, we see those smaller groups within the arrangement. So if some examples of composite numbers would be 4, 6, 8, And you might be saying, okay, so it's obviously just even numbers, but it's not just even numbers, because like 9 is 3 times 3. And you have 12, and then once again, another one that's not even, 15, because it's 3 and 5. So there are lots of composite numbers as well. Many, many more composite numbers than prime numbers. So what we're going to do is we're going to do a little activity down here called the Sieve of Aristophanes, where we can actually look at how primes are found. Now we're only going to focus up to the number 50. If you can get your way all the way up to 100, that's fabulous. There's computer models out there that are constantly creating and working on primes. So there are really, really, really big prime numbers, which seems weird because you would think a number would be too big to be prime, but that's not always the case. So what we're going to do is we're going to circle the prime numbers and then cross out the multiples of those prime numbers to basically find just the primes and get rid of the composites. One thing I want you to notice both here in this visual is the number 1 and how 1 isn't circled here. 1 is a special case because 1 only has one factor itself. It is neither prime nor composite. And 0 is another special case as well, that 0 does not work as either. So we are going to put a big X through the number 1 because it is not prime nor is it composite. So 2 is our first prime number. It is the only even prime number. Now I'm going to go and cross off all the multiples of 2. So think about skip counting by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 8, 30. And what I'm doing here, because I'm crossing off the multiples of that number, by definition, the multiples of 2 have a factor of 2, giving it an additional factor, making it composite. So all even numbers, except for the number 2, are composite. All right, our next prime number is 3. So now we're going to go through and cross off our multiples of 3. So 3, 6 is already crossed off, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. Since 4 is already crossed off, we skip 4 because anything that's a multiple of 4 is also a multiple of 2 since 2 is a multiple of 4. Our next prime number is 5. So I'm going to circle 5. And then I'm going to cross off all of my multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now we skip 6 because it's already crossed off. So our next prime number is 7. I'm going to do the same thing. So 7, 14, 21, 28, 35, 42, 49. Now we move on to our next number. So our next number that's prime is 11. So 11, and we look at 22, 33, 44, and that's it. So our next number is 13. So 13, 26, 39. And at this point, we've gotten far enough because as we start to look at, so when we double 17, that becomes 34. And then it's 51, 19 would double to 38. We've crossed off all of our composite numbers. So at this point, anything that's left is now a prime number. So here we have all of our prime numbers up through 50. All right, so on your own, go ahead and answer those questions. Except for the number 2, what do all prime numbers have in common? and then pick one composite number and list all of their factors. But this is it for our video. Let me know if you have any other questions.